We tend to measure the scale of our civilization by its active volume. We concentrate millions of individuals into tight geographic spaces, creating constant flowing movement through concrete intersections. We engineer massive cultural gatherings, packing tens of thousands of people shoulder to shoulder in dedicated arenas. And we generate exabytes of data, processing our daily lives through rows of silent, endlessly humming server racks. But what happens when the motion stops? Agar sab chhodkar chale jaye, to kya bachega? If everyone leaves, what will remain? This active motion is only the surface of our footprint. The environments we build and the tools we rely on wait to become static artifacts the exact second we stop maintaining them. To accurately map our long-term footprint, we have to look past the achievements of the present and analyze the specific layers of residue we will leave behind. The breakdown of our physical world begins within hours. Without human intervention to manage power grids, subways flood as groundwater pumps fail. Within months, unchecked moisture introduces aggressive corrosion to critical mechanical infrastructure. Give it a few decades, and root systems fracture concrete foundations. Entire residential blocks disappear beneath a canopy of dense new forest growth. Over a few centuries, the continuous assault of freeze-thaw cycles and oxidation will take down our tallest monuments, reducing steel and glass skyscrapers to unrecognizable mounds of debris. In extreme environments, this decay process accelerates. Saltwater and coastal winds aggressively erode reinforced concrete, tearing down imposing industrial monoliths in a fraction of the usual time. We pour millions of tons of resources into erecting these urban centers. Yet the physical architecture we build is actually the weakest and most temporary layer of our legacy. Our more permanent footprint requires a microscope. Geologists track what are known as technofossils, the distinct chemical markers and synthetic microscopic particles we embed directly into the Earth. This diagram shows a cross-section of geological strata forming over millennia. Notice the unnatural layer of particulate matter settling above the natural bedrock. These are synthetic microplastics, compressing into a permanent layer of sedimentary rock. Looking at the topsoil level above, we see another permanent alteration. The global scale of industrial agriculture has irreversibly shifted concentrations of nitrogen and phosphorus across the planet's surface soil. The absolute longest-lasting chemical marker, however, comes from our energy sector. Radioactive isotopes produced by nuclear testing and power generation possess half-lives that will emit radiation for tens of thousands of years. Long after the final steel girder turns to rust, the chemical makeup of the Earth's crust will serve as a silent, unerasable barcode proving an advanced civilization lived here. The vast sum of our modern knowledge is stored on physical mediums with surprisingly short lifespans. Magnetic tape and server hard drives require strict climate control to prevent total data loss within a few decades. Our most resilient records exist entirely off-planet. In the early 20th century, we began transmitting high-powered analog television and radio broadcasts. Every local news report and variety show started leaking upward, slipping past the atmosphere. This is a simplified model of the Milky Way galaxy. The expanding spherical bubble you see centered on Earth represents those original electromagnetic waves traveling outward in all directions at the speed of light, entirely unimpeded by the physical decay happening on the surface below. Our ultimate legacy is a faint, expanding sphere of digital ghosts, drifting through the vacuum of the cosmos for millions of years. A modified biosphere, synthetic layers compressed into bedrock, and a faint hum of television broadcasts in deep space. This is the exact sum of what remains. Understanding these specific layers changes how we evaluate modern consumption and urban design. A skyscraper is a temporary arrangement of minerals. A plastic container is a future geological feature. Every object we manufacture today is merely a fossil in waiting, destined to break down and join the permanent sedimentary record. We spend our lives building for the immediate present, but through the materials we extract and the waste we generate, we are inadvertently architecting the ruins of tomorrow. We will leave a permanent signature in the soil and the stars. The question is whether we are truly comfortable with the legacy that will echo in the silence after we are gone.